Morning, gentlemen. Mr. Novak here, and just doing a little video on special terminology used in geometry. So it's all about terminology, and the terminology is the angle of elevation and depression. In other words, we could give you a worded question, no diagram, and you are supposed to know exactly which angle we are referring to. Remember, there are two angles in the right angle triangle that we may be wanting you to calculate. The language is the angle of elevation or the angle of depression. There are two phrases used, but one thing is very assuring of that, and that is it's always, repeat, measured from the horizontal line. So here we have the angle of elevation, remember, measured from the horizontal line. And that is as if you were looking up at an object. In other words, you're tilting your head up. We call that the angle of elevation. You might be looking at a bird. The other angle that we may refer to is if you were, say, looking down, say, from a cliff. And again, it's important that you do not use the cliff face, because I'll talk about the cliff face being, say, 80 meters long. Do not use that. The angle that is always measured from the horizontal line. And so we want this angle here. The common mistake is students to calculate that. So let's have a look at an example. But before I go there, there is a thing called the alternate angle law. So as a very useful law, especially in anything to do with navigation as well. And the law is a very simple one. That is that when we have parallel lines, let's say the horizontal line of are always parallel. But if we have parallel lines and we cross it, you'll notice that these two angles here, that one there, maybe a darker one, this angle here and this angle here are the same. In other words, if I went around that angle there and I went around that angle there, we can see that they are the same angle. Now, that's a very useful law, and you can easily see it. That letter Z came along. And so we say that angles are the same, or are equal, actually. Now, how is that useful? Well, very simply, often you will be asked to, for instance, work out the angle um, from the, let's call it, say, from the angle of elevation. You'll be looking at up. But you might have another person who is at the top there, and he'll be asked to look at the angle of depression from B to A. So they are basically looking at each other. And remember, yes, angle of elevation is measured from the horizontal. And this is where it's important you don't make this mistake. Do not do the vertical line, do the horizontal line, the angle of depression from B. And you can see that we have that letter Z. In other words, these two lines are parallel, so these two angles must be the same. So that's a useful rule. The angle of elevation from A to B is equal to the angle of depression from B to A. And the best way for me to demonstrate the importance of that law is when we're looking at this question here. So very simply put, as I say, it's a worded question, no diagrams. Which angle are they talking about? So you do a quick drawing of it. There's your drawing of a building. Okay, there's a building. We're looking at the ground. Someone from the top of the building, which is 50 meters high, looking down at the ground, which is about 80 meters from the base. And here's where a lot of students, as soon as you see that, you see this triangle here, and And you think, oh, the angle they want me to measure is this angle here, but it's not, because that's not the horizontal. Remember, the angle of depression is measured from the horizontal. But majority of you will now see the letter Z, so we can see that we're going to use that angle there. Angle of depression is the same as the angle of elevation from the ground up to the top of the building. So we draw the scenario out. Oops, let me pause that while I get the proper diagram. Okay, I've gone back, there it is. So there's the diagram. Remember, they want us to find this angle here, the angle of depression measured from the horizontal, but we're clever enough to recognize that those two angles are the same. So I'll draw it out nice and simple. There it is there. The right angle, assuming the building and the ground are at right angles. The angle they are referring to is in actual fact that angle. I know it's from there, but we're using the simple rule, the alternate angle law, and we can now label. You know me, I always like to do the hypotenuse because that never changes. I like to do the one that's next to the angle that we're interested, that's the adjacent, and that leaves us with the opposite. As you can see, we're interested in O and A. So that's the tan ratio. So putting in there tan theta equals A, substituting tan theta equals 50 over 80. Theta equals, remember, we can go to our calculator, and if we're using just the calculator, the trig button, you just simply go trig. Remember, it's the second row of the, if you know the ratio, find the angle. Inverse tan of 50 divided by 80, and we get 32.005, which is near enough to 32 degrees. So simply put, 32 degrees. But don't forget, they ask you for the angle of elevation. So you're right. So no, angle of depression from top of the building is 32 degrees. Okay, there you go, gentlemen. Thank you very much.